All right, we are on the third day of Heating Earth, page 200, Global Warming. Global warming. Over the past 100 years, Earth's average surface temperature has increased by about 0.5 degrees Celsius, half a degree Celsius, or 0.9 degrees Fahrenheit, about 1 degree Fahrenheit, rounded up. This trend of rising temperature is known as global warming. Over the same period, concentrations of carbon dioxide and other greenhouse gases in Earth's atmosphere have also risen gradually. The graph below shows the increase in carbon dioxide over the past 50 years. Okay, past 100 years, plus squiggle, 1 degree Fahrenheit, so about a degree. 0.9 is about 1. Greenhouse gases, open parentheses, CO2, close parentheses, arrow up. Greenhouse gases have been going up. And we'll go on from there. Recall that greenhouse gases trap heat, warming Earth's surface and the lower parts of the atmosphere. Increased concentrations of greenhouse gases would work to enhance Earth's natural greenhouse effect, further warming the planet. Okay, trap heat, zoop, warm planet. Where does the extra carbon dioxide come from? Most scientists agree that human activity is responsible for adding carbon dioxide to the atmosphere. Burning of fossil fuels produces carbon dioxide. Humans are also cutting down or burning forests. As you may know, plants take up carbon dioxide as they grow. So, human activity, indent, burn fossil fuels, indent, E period, G period, for example given. They don't say this in the book, but I'm giving you these examples. Natural gas, zoop. Coal, C-O-A-L, zoop. Gasoline, like for your cars and trucks. Cut/burn forests. Plants, quote-unquote, take up CO2. So plants take that CO2 in, use photosynthesis to create sugars for energy for themselves. The carbon becomes the structure of the plant, the leaves, the stems, the trunk, the roots, and then the oxygen goes back out in the atmosphere for animals and humans to breathe. So a lot of that carbon is getting trapped inside the tree, the trunk, the roots, the leaves, the stems, everything else. But if we cut down and burn forests, all of that carbon is getting released back out into the atmosphere as carbon dioxide. Same thing when we burn natural gas for heating our homes or for generating electricity. Same thing for coal, same thing for gasoline. Rising average temperatures would eventually melt the ice sheets on Greenland and Antarctica, as well as mountain glaciers. Global ocean levels would rise as a result. Most scientists agree that global warming is occurring and that human activity contributes to greenhouse gases. However, scientists disagree about the importance of the human contribution compared to natural variations in climate. Today, scientists and government leaders continue to discuss global warming and its possible consequences. Okay, now today it's mostly referred to as climate change rather than just global warming. Now, in our notes, melt ice/glaciers, arrow sea level rise. Okay, so that's one of the effects of these human activities. What's going to happen if the sea levels rise? Well, it's going to change weathering and erosion, which we learned about early on this year. It's also going to affect the water cycle, zoop, weather, zoop, and climate. So remember, weather is like what weather you're having any given day. It's raining, it's windy, whatever, how hot or cold the temperature is. Climate is what is it like in general. Is it a wet coastal area with a lot of fog? Is it a drier valley like where we live? Is it a very dry and hot desert like over on the other side of the mountains? Climate is a little bit different than weather. Okay, now, how might the atmosphere change if people burned less fossil fuel? Okay, if people burned less fossil fuel, then the atmosphere might have fewer greenhouse gases in it. If there's less greenhouse gases, that's going to trap less heat, so we're not going to have as much of a global warming problem. In fact, maybe the temperature would be even more steady and not change this degree. Now that degree change was years ago, however long ago this book was made. It's now up to around, I think, 2 or 3 degrees Fahrenheit in modern times, since this book has been printed. Okay, next question. How might rising temperatures affect coastal areas on Earth? Rising temperatures might affect coastal areas on Earth by raising the sea level. So we might see more weathering and erosion along the coast. And remember when we learned about beaches and cliffs and sea arches and sand spits and all those other landforms, we know how weathering and erosion can be affected by the ocean and the currents and the waves. That in turn is going to affect the water cycle, the weather in those areas, and the climate. Okay, next up, you want your highlighter and you want your red pen or crayon or red pencil. Now we're going to use the visual summary to highlight. Okay, visual summary. Uneven heating by the sun causes some regions on Earth to be warmer than others. Okay, so uneven heating. Highlight the main idea, energy from sun, not heat Earth evenly. Highlight uneven heating. And then what things are they actually talking about when they say that? Earth heated unevenly. Higher latitude curves away. Energy spread out. So the reason the Earth is heating unevenly is because of the higher latitude and the curving away. So the energy is spreading out. Also, this same angle effect is happening due to rotation. In other words, in the morning it's cool, but in the afternoon it's hot. Also, that angle causes a longer path, so the atmosphere absorbs, reflects, or scatters light. Also, the tilted axis changes things. In the summer, when the northern hemisphere is tilted towards, it's hotter. And in the winter, when we are tilted away, it's colder. Okay, notice that we had to add something here. In Earth's energy balance, about half absorbed at surface, and here's why. About half of the solar energy that reaches Earth is absorbed by its surface. We needed to add that right here. An arrow from tiny fraction actually received. About half absorbed at surface. Highlight that. This energy is released by the surface as infrared radiation, warming the lower atmosphere. Okay, Earth's temp, squiggle steady. When we did the clouds drawing, IR, re-radiate, warm. So the Earth's temperature is pretty steady because the surface and the lower atmosphere are absorbing that infrared radiation. So it's keeping things a little bit warmer than they would get at night. Remember how we learned about comparing to the moon? Without an atmosphere, all that energy just escapes to space and it gets freezing cold. Okay, greenhouse gases in the atmosphere help moderate Earth's surface temperatures. Earth atmosphere moderates temperature, steady. The Earth's atmosphere helps moderate the temperature and keep things steady. Greenhouse effect traps energy. Greenhouse gases. Some greenhouse effect is needed for life. CO2, carbon dioxide, because that's one of the most important greenhouse gases for what's going on. And when we get on to global warming, CO2 is the big change here. That's what's changing. Highlight global warming. Highlight past 100 years, plus about 1 degree Fahrenheit. Highlight greenhouse gases are going up. Highlight human activity. Highlight burn fossil fuels. And then I ran a highlight down the side here because all of these are effects. So now get your red pen out and write this with me. Significant, SIGNIFICANT. Effects, ECTS. Significant effects. Melting glaciers, rising sea level, weathering and erosion changes, changing the water cycle, changes in weather, changes in climate. Those are all significant effects. That's the same thing as saying large-scale consequences. Large, LARGE, dash, scale, SCALE. Consequences. Say that word, consequences. 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 So significant effects or large-scale consequences are happening. Now, use the red pen, highlight the main idea. Annotate. Annotate energy, annotate sun, annotate evenly. Okay? Annotate, Earth heated unevenly. That's the main thing of this entire lesson. We're learning about how the Earth is heated unevenly. Annotate energy spread out. That's why. Now, why is the energy getting spread out? Latitude, underline it. Okay? Annotate same angle effect. That's causing things to spread out. Why? Because of rotation, underline it. What's another thing similar to changes in latitude or similar to the Earth rotating around its axis and spinning? Tilted axis, underline tilted axis. It's really important that only about half of the energy that gets to the Earth is actually absorbed by the surface. Only about half the energy is what's keeping us warm. Annotate it. Okay. The Earth's atmosphere is moderating temperatures and keeping things steady. Annotate it. That's why we're able to live and have life on Earth. That's why we have steady temperatures. Okay, down here. What's doing that? The greenhouse gases. Annotate it. Greenhouse gases in the Earth's atmosphere are moderating temperatures and keeping things steady, which allows for life on Earth. Okay? Only about half of the energy gets in, and things are different depending on the tilted axis, the rotation of the Earth, or what latitude you're at. That's why the Earth is heated unevenly. In the global warming section, annotate the past 100 years that it's been changing. Annotate the greenhouse gases are doing it, and annotate human activity. We're not going to say each individual human activity, but we're going to say that over the past 100 years, temperatures have increased due to greenhouse gases going up. That's because of human activity, and it's going to have significant effects on our planet. Annotate significant effects. Okay, one last time, go to the front and make sure you have everything. Highlighted, star, 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 highlighted, star highlighted, highlighted with an underline of latitude, highlighted star, star highlighted, underlining rotation, highlight, 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 tilted axis is underlined, summer and winter, half absorbed at surface, that's annotated, highlighted Earth's temp is steady, IR and warm, highlighted Earth atmosphere moderates temperature steady and annotated, highlighted greenhouse effect, traps energy, greenhouse gases, some GE needed for life, CO2, annotated, global warming, past 100 years plus a degree Fahrenheit, greenhouse gases are going up, human activity, burning fossil fuels, all these things. Annotate that it's been 100 years. Annotate the gases are going up. Annotate human activity. Annotate significant effects. Okay, now that's all of phase 1 and phase 2. Now you're going to go do phase 3. I know, I predict, I wonder in your e-binder. All right, good job persevering with the growth mindset. Go do your phase 3 in your e-binder and roar Wildcats.